In this problem, we are going to minimize the total cost to this company of purchasing their copper. So this is a classic minimization problem. We have costs associated with delivery, and then we have costs associated with the storage. We add these together, and we're trying to minimize them. Typically, minimization problems, you have costs, you find critical numbers, you evaluate using the first or second derivative test to figure out whether those critical numbers are positive or negative. Normally, you would choose that critical number, assuming it represents a minimum. Here, we have to be a little bit careful because we have a minimum order size of 10,000 kilograms and a maximum order size of 30,000 kilograms. So that might affect this problem. Okay, so the way this problem is set up, we're going to split the costs into delivery and storage. So let's talk about delivery costs for a second. So the company requires 150,000 kilograms of copper. The distributor has a minimum and maximum order size. There's a fixed delivery charge of $3,950 per delivery, and 1 kilogram of copper costs $10. Okay, so first, we're going to let N be the number of deliveries. And I'm writing this down so that whenever I use N, I remember what it means or have a chance to look up and see what it means. Okay, so we're looking for delivery costs. Now we're going to do N deliveries. So C sub D of N is going to be N times, now each delivery costs us $3,950 plus $10 times number of kilograms of copper. So 10 times 150,000 divided by N. Right, 3950, that's our fixed delivery charge. 10 times 150,000 over N. 150,000 over N is how many pounds of copper, or how many kilograms of copper get delivered, $10 per kilogram. Okay, so let's just simplify that a little bit. So that's 3950 N plus $1.5 million. Right, now the $1.5 million is a constant. Why? Because we always pay $10 per kilogram. We eventually order 150,000 kilograms, therefore 1.5 million. Okay, that's our delivery costs. Now our storage costs are a little bit harder. Again, we're going to have this N, and then we need to think about the storage cost for a given delivery. That's how we're going to think about it. Okay, now the trick in this one is to think about a delivery of copper. And the assumption is that we use the copper uniformly throughout the year. That's an important assumption. That's our second assumption there. It costs $6.50 to store a kilogram of copper for a year, and we're assuming that storage costs are proportional, meaning $3.25 for half a year, half of that for a quarter of a year, and so on. Okay, so the real question here is, how long does a kilogram of copper get stored? And the best way to think about this is that if I get a delivery of copper, I'm going to use that sort of continuously throughout the time on which the delivery happens. So let's say I delivered once a year, then I would get 150,000 kilograms of copper. The first kilogram gets used immediately. The last one gets used at the very end. The next kilogram we wait is in storage for a short period of time, pretty short. The second to last kilogram gets stored for almost the entire period, but not quite. And if we think about this carefully, what it means is that each kilogram of copper gets stored for half the time between deliveries. Okay, so armed with that knowledge, we've got to say how long is it between deliveries? Well, that's 1 year divided by the number of deliveries, so 1 over N. Each kilogram of copper gets stored for half of that time, so 1 over 2N. And now we just have to say, well, hold on. We have $6.50 it costs per kilogram. And then, of course, each delivery, there's 150,000 over n kilograms of copper. So this is our storage costs. I'll multiply this out. We're going to end up with an n in the denominator, and then in the numerator we've got 150,000 times 6.5 divided by 2. So that is, the storage costs are 487,500 divided by n, just multiplying everything out. So that gives us a total cost, which is 3950 n plus 1.5 million plus 487,500 over n. We're trying to minimize, so we're going to take a derivative and find critical numbers. So let's just do that. So there's our total cost equation. Take a derivative, so c prime of n equals 3950. And then this term, we've got an n to the minus 1. So that's going to be minus 487,500 over n squared. To find a critical number, we set it to 0. 0 equals 3950 minus 487,500 divided by n squared. And that means n equals plus or minus the square root 487,500 divided by 3950. And of course, we're not going to care about the negative square root, so we'll just calculate this. 487,500 divided by 3950. Take the square root, and we get 11.11. So critical number is n equals 11.11. Now I am going to look at, let's see here, we're going to look at a number line perhaps. Probably the easiest way to do this. So that's 11.11. This is the derivative. And we look at a big number. A big number is going to make this smaller, right? 487,500 divided by a big number squared. So that's going to be a smaller number, and we're going to end up with positive here. And if we put in a smaller number, like 1, we get a negative number, so we get a negative number there. So the function itself is decreasing and increasing. So 11.11, the cost at 11.11 should represent a minimum. There's only one critical number, so it's an absolute minimum, but we just need to check one last thing, which is, can we take 11.11 deliveries? So we need to check that if we take 11.11 deliveries, is that between the minimum and maximum order size? So let's just check. We do 150,000 divided by 11.11, and we get 13,501 kilograms per delivery, which is acceptable. So the cost at 11.11 should represent an absolute minimum. And let's just calculate what that is. So we'll go back up here. Cost at 11.11 is equal to, let's pull out our calculator, 3950 times 11.11 plus 1.5 million plus 487,500 divided by 11.11, and we get costs of 158,764. So let's go through, put all our numbers in. The delivery cost was 3950 n plus 1500, 1.5 million. Got that right? Okay. The storage costs were 487,500 divided by n. The total cost is just the sum, 3950 n plus 1500000 plus 487,500 divided by n. The derivative of total cost was 3950 minus 487,500 divided by n squared. Number of deliveries, 11.11. The minimum cost 1587 764, sorry. 764. My handwriting is not being very good today, so 764. Let's check. Got that first part correct, second part, third part, fourth part, fifth part, and sixth part correct. So that's the correct answer.